Hello, everyone. Welcome to our Grammarly AI-NLP Club meeting. My name is David Rojas. I'm an analytical linguist manager at Grammarly, leading intelligence features and outcomes teams in North America. Together with computational linguists, machine learning engineers, applied research scientists, and many other partners in product design and engineering, the analytical linguists at Grammarly work on a wide range of features intended to help our users improve their communication and achieve their goals. The Grammarly AI-NLP Club series brings together international leaders and specialists in AI, in machine learning, and natural language processing to share high-quality research content and learnings. Today, I am very pleased to moderate this meetup featuring two of my colleagues, Lily Eng and Lena Nahorna. These events are intended as an opportunity for you to connect with new and interesting people with Grammarly and with each other. So after the talk and the Q&A session, we invite you to join a Zoom call for a more informal group conversation. There, you'll have a chance to chat with our speakers, Lily and Lena, and others from the Grammarly team. You can find the link for that call in your registration confirmation, and we'll also post it in the Zoom chat here at the end of the presentation. So you're very welcome and encouraged to come talk with us and with each other. So a little bit more information about the session. During the presentation, please submit your questions using the Q&A feature, and our speakers will address those after the talk. And rest assured that there is an opportunity to ask Lily and Lena about the things you're most interested in during the networking session too, so don't miss that chance as well. With these logistical matters behind us, let's now get to the main part of today's meetup. I'm thrilled to welcome Lily and Lena to Analytical Linguists at Grammarly to tell you more about collecting high-quality data to power machine learning systems.
Hi, everyone. My name is Lily. I'm an analytical linguist, as David mentioned. I've been at Grammarly for about 3 years now. Before working at Grammarly, I was finishing my master's degree in computational linguistics. And my main focus as an analytical linguist is on improving our annotation practices and our annotation infrastructure.
Hello, everyone. My name is Lena. I'm from Ukraine, and I've been working for Grammarly for around 3 years. I'm a PhD in linguistics, and prior to Grammarly, I spent 11 years working as an ESL teacher. And my primary focus at Grammarly is GEC, which stands for grammatical error correction. All right then. So before we get down to the presentation, I'd like to give a brief overview of our talk. And in today's presentation, we'd like to share some insight into annotation best practices. We'd like to share and we'd like to give you some tips that you might find useful when preparing your task, tips for designing your annotation and tips for working with annotators. Besides that, we'll be talking about ways to measure the quality of your annotated data set. So who is this talk for? So this talk might be of interest for language engineers or analytical linguists like Lilian and me, and NLP research engineers and researchers, data scientists, computational linguists, machine learning engineers, and generally anyone working with language data or developing models. It's also worth highlighting the high-level goal of the presentation. Well, the goal that we are setting here today is to raise awareness around annotation best practices and stress that higher data quality means higher model quality. And that can be achieved through proper annotation management. Besides, we'd like to shift focus from data quantity to data quality, which aligns with the data-centric AI, a movement in the field of artificial intelligence that focuses more on data quality rather than the amount of data collected. All right, well, at this point, I'm happy to hand it over to Lily, who will present annotation design principles.
Hi, everyone. To kick off the presentation, I'll walk through some important points to consider before your annotation starts. I'll start by highlighting questions to ask yourself about data sampling and preprocessing. I'll outline different types of annotation, and I'll wrap up with principles to keep in mind as you're designing your task and your interface. It's important to be intentional about how your data set will be used and do your best to anticipate requirements and identify nuances for your data set before your annotation starts. Here are some questions you can answer before collecting annotations on a data set. So let's walk through these questions together and imagine that we're creating a data set we'll use to assess the quality of our grammatical error correction model, which I'll refer to as GEC. First off, how will your annotated data be used? We're creating an evaluation data set, which is also known as a test set or a gold standard set. And the purpose is to assess the quality of our GEC model, which offers correctness suggestions on any written text. I want to test model performance on multiple domains, for example, internet text like blog posts, and also more formal writing such as essays. Should you target even or representative sampling? Others may approach this differently, but I want to make sure that every possible domain is present in my evaluation set so that I can identify how the model is performing against all of these classes. Therefore, I will use even sampling in my eval set so that every domain is present. Another option is to create separate evaluation sets specific to each domain. If I find that my model is performing poorly on a particular domain, I could then supplement my training data with more instances from this domain. This domain may have been underrepresented in my training data. Next is how much noise is tolerable. First of all, noise can refer to both messy, unlabeled data and also inaccurate or incorrect annotations. In the context of data sampling, which happens before data is annotated at all, noise is any raw data that might be ungrammatical, truncated, incomprehensible, or otherwise may not be fit for annotation. In my case, I will allow for some noise in my data because I want my model to treat these messy data points correctly. For example, for the GEC case, there are some cases where I don't want my model to make any grammatical suggestions at all because my input is too messy in the first place. So I'll make sure to include these in my eval set so I can see how my model is performing on those. Finally, how big should the data set be? In general, my evaluation set can be smaller than my training set. Let's say I'm evaluating how my model performs on 10 different domains, and I want at least 100 instances per domain in my data set. So overall, my data set will be 1,000. And there's no right answer to this. The size of the data set will be dictated by the annotation resources you have available, and also the timeline that you're following for your annotation. To document your decisions and foster alignment between different stakeholders working on your task, we recommend creating a dataset specification template that you can fill out for every new dataset you're creating. Having this written down will allow you to refer to this in the future and also to iterate and improve on this specification. We also recommend creating multiple versions of the specification, one for each stage of annotation, which is something that Lena will touch on later. So overall, do your best to think through challenges early on, but keep in mind that unanticipated issues will come up inevitably, and it's essential to be flexible. Once you have your data specification doc filled out, think about how to sample and pre-process your data for your specific use case. If you're not training your model yourself, it's really important to think in collaboration with a person who is responsible for this so that you can understand any technical requirements of your model. So starting with sampling, where should your raw data come from? Are you interested in covering one type of data specifically, or do you want coverage of different kinds of data? The data source should reflect the downstream application of the data set. So continuing with my grammatical error correction evaluation data set that I'm creating, I'm interested in seeing how GEC performs on multiple domains. So I need to make sure to sample from every domain that I'm interested in. I'm also only interested in evaluating my model on English texts. So I need to make sure to sample or filter accordingly using some kind of language detection. I also want to make sure that my data are sampled over a longer period of time, not just one day, for example, so it's more representative and not biased. For example, if I'm sampling from social media posts and I only sample over one day, it's really likely that the post will contain a lot of content that's related to a particular topic of the day, such as a news event. So it's important to think through these biases that you could be introducing by your sampling method. Preprocessing. How do you need to clean and filter your data? Will you filter out certain content that doesn't need to be annotated? As I mentioned before, I'm going to include some social media posts in my data set, let's say tweets. I don't care about annotating retweets or tweets that are just URLs, so I'll make sure to remove these from my data. I also don't want metadata content like dates and Twitter handles to be annotated. So I'll remove these from my data, but I do want to preserve this information as metadata. This is another important thing to keep in mind. What metadata do you need to preserve for proper analysis of the text down the line? I also want to make sure to remove duplicates from my data set, since I don't need annotators to provide grammatical corrections to the same text twice. Finally, you'll consider how your data needs to be prepared for your annotation. In my case, my model can be trained only on single sentences, so I need to make sure to split my raw data into single sentences to show to annotators. But you may choose to show annotators more than one sentence or a paragraph at a time. There really isn't any right answer to any of these questions. It really depends on your use case and what you want your model to be able to learn. The best thing that you can do is to look through your data to yourself to flag any issues before annotation starts. Now that we have our data set, we're ready to annotate. There are a few different types of text annotation tasks, increasing in complexity from left to right. As the complexity of a task increases, so does the complexity of evaluating these annotations. The more complex the task, the more subjective the quality of the annotations. To start, a labeling task is one in which annotators choose one or more label to apply to the entire text or just a part of the text. And there are a few points to consider when running a labeling task. First is, are you doing binary or multi-class labeling, or how many labels will your annotators choose from? Keep in mind that the more labels you have, the more complicated the task is for the annotators. Next is your task multi-label, meaning can a given input have more than one label assigned to it? If so, are the labels flat? Are they ranked? Is there some kind of hierarchy between them? To evaluate the quality of labeled data, you can use inter-annotator agreement as long as you have more than one annotator labeling each input. And this is something I'll touch on later in the presentation. Next is a transformation task, which is one in which annotators are editing or rewriting your input. And these tasks are more complex to evaluate than labeling tasks, and you'll need to measure quality with a metric other than inter-annotator agreement. Finally, we have a generation task, which is one in which annotators are creating content from scratch or based on other content. For this type of task, you will need to measure quality using a metric other than inter-annotator agreement. Regardless of the task type, you have to consider redundancy, which is the number of annotators who will annotate each input. In general, it's a good idea to collect more than one reference or annotation for each data point, especially at the start of a task, at least for a subset of your data set. For labeling tasks, this is so you can calculate agreement. For transformation and generation tasks, this is so your model can learn multiple ways to treat a given input, and it isn't too biased toward one annotator. Here are a few principles to keep in mind when leading an annotation project. At a high level, you should think of annotation as a user experience problem. What is the right question to ask to get the data that you need? How do we make it as easy as possible for annotators to provide data? We need to use annotation time wisely, so we have to think about efficiency and ease. Try to design your task from your annotator's perspective. The best way to do this is to do your annotation task yourself before you give it to annotators so that you can find any issues with design. The first principle is to keep your task simple. You don't want the cognitive load of your task to be too heavy because annotators will get tired and lose focus. So you should try to break your task down into small, separate tasks if possible. For example, you can have more than one round of annotation and only ask annotators to do one task at a time. For GEC, I might ask my contributors to first decide whether or not the text can be corrected, which is a binary labeling task, before editing the text, which is a transformation task. Second, prioritize efficiency. Annotator time is valuable, and by using time efficiently, we will also minimize the cost of our annotation. Since annotator time is valuable, you should only gather annotations when they're actually needed. And there are a few ways you can do this. The first one is pre-labeling or programmatic labeling, which is a method to enrich your data automatically by applying labels to your data using model predictions or perhaps a heuristic that you developed yourself. Once you have these labels from your heuristic or model, you can hand these off to annotators to validate, or you can exclude these label instances from your annotation altogether. Another method for efficient annotation is human-in-the-loop machine learning. This is a method used to supplement human judgment with machine learning and machine learning with human judgment. Active learning is one approach to human-in-the-loop machine learning. In an active learning setup, the model chooses examples that it's not sure how to treat as you train it. And these examples become input for human annotation. As a result, annotators are only seeing instances that the model has a low confidence on. This requires training a model iteratively and using the model's confidence scores to select data. You can either write your own code to do this, or you can use an existing annotation platform that supports this. Finally, your annotation interface should be easy to use. The interface should work for annotators and not slow annotators down. Ideally, annotators should be able to go back and review and change their annotations. This can help raise the quality of your data set as annotators become more familiar with your task. Annotators should also be able to use the keyboard more than the mouse. This is more ergonomic. And finally, annotators should be able to access the guidelines on demand for easy reference.
All right, let's move on to the next part of the presentation. Right now, we're going to cover several important items. First of all, we'll discuss what the guidelines creation process looks like. After that, we'll pay special attention to what stages the annotation process embraces, along with principles of effective communication with annotators. And yeah, let's talk about the guidelines. Guidelines are basically the instructions that your annotators will follow when they will process your data. Writing the guidelines is a complex process, although following the right methodology will help you produce a decent set of instructions. So yeah. Before you get down to writing the guidelines, you should conceptualize the problem. First of all, you might want to do a lit review in order to research prior works on your topic and see what's been done in the field. After that, you should connect the theory to your product needs. For instance, style guides may recommend, may say that an Oxford comma is an optional element, right? So this is the right stage for you to make a decision whether this element is required and whether your users want to see this suggestion. Well, once you put all these pieces together, both theoretical and practical, feel free to just solidify the definition of your annotation subject. And once you have everything in place, well, it's about time to write the guidelines. For the guidelines, it's essential that you find the balance between your text being too short and sweet and too detailed and comprehensive. So length can be a problem, right? And the good rule of thumb is that your guidelines have to deliver a sufficient level of context, but must be written in the most concise way possible. Guidelines, just like any other scholarly paper, is it just piece of writing that has to be peer reviewed. So as you write the guidelines, try to seek feedback from your peers. It's essential because the more pairs of eyes see the text, the more comprehensive the topic description will be. And yeah, we all know about the synergy effect. All right, well, we're getting close to the end of the process. After drafting the guidelines, you are welcome to validate them. And yeah, this is something that I'm going to hit soon. You can validate your guidelines during the pilot annotation stage. That's the best venue to do that. That's a rehearsal of your large-scale annotation. So you get plenty of questions and you can incorporate the feedback you get from annotators and revisit your guidelines. And yeah, it's not that I mean to be boring, but please have your revisited version of the guidelines peer reviewed by your colleagues, right? Okay, well, it's been a description of the guidelines creation process. So now let's have a recap and crystallize the aforementioned into guidelines best practices. So if you want to create guidelines well on a permanent basis, you may want to follow these tips. In order to write guidelines properly, you have to use proper language. Avoid complex terms. Just because you know what a perlocutionary effect means doesn't mean that everyone will understand that right away, and doesn't mean that your pool of annotators will grasp that immediately. And that's not because they are unprofessional. That's because they may come from a different background. Eliminate ambiguities and inconsistencies. In other words, make sure you don't ask your annotators to put and not to put an Oxford comma. So that might sound silly, but that sometimes happens. Test your guidelines. Grab the document that you've written and follow your own instructions. That will point you to the frictions in the process that you actually ask the annotators to follow. Also, ask peers to follow your instructions, and you'll just get another portion of feedback. Context and illustration. Well, at times, annotation can be mundane. Let's say you may ask annotators to classify sentences into grammatical and ungrammatical. However, explaining the reasons why you need that can change things, right? Let's say you can tell them that they need to do this classification project because that will enable you to measure the model precision, right? And you can understand the percentage of correct suggestions that your model produces. And rest assured that that will make the process way more meaningful to annotators. Also, provide examples and counterexamples. Counterexamples are very important because, let's say, when you ask annotators to introduce grammatical corrections, annotators can introduce anything that goes beyond the scope of GEC. That's why it's important to give some counterexamples and just to show them what's not GEC. Version control. Establish a process for version control, and you may wonder why it's important. That will help you track your decisions, and all your decisions will be referenceable, right? Guidelines will have version numbers, and any changes between versions will be able to be tracked, and the annotated data can be associated with a certain set of guidelines. In other words, you'll be able to use your guidelines as a separate element of your dataset specification. Good. Let's move on to the annotation process. Well, as you may have guessed, an annotation is another complex process, and it consists of multiple stages. Each stage possesses its own specificities. And of course, annotation is never about rigidity. So one and the same project can be tailored and set up in a number of ways, and it depends on various factors. Let's say the data volume, the number of annotators, your task and design novelty, and many other things. Nevertheless, we can outline a skeleton that will be reflective of major stages and their sequence. Well, if you look at this slide, you'll see three stages: a pilot annotation, a large-scale annotation, and a retrospective. So let's talk about each of them. Pilot, what does it mean? It's simply, like I said before, it's simply a rehearsal of your large-scale annotation. And the purpose of this stage is manifold. Primarily, this is to test your annotation project plan. And as a side benefit, you can prepare your annotators for the task if the very same pool of annotators is going to work on the large-scale project. And yeah, let's suppose this is your case. So yeah, how do you launch a pilot? Well, first of all, you need to make sure your annotators are well familiar with the guidelines and have a decent understanding of the annotation process. A calibration can help you do that. A calibration represents a small task that the pool of annotators will complete. You will then check it. And after that, you can share your observations with annotators. In particular, you can point to some instances that you might have done differently, or let's say you can point to some good examples, and that will help them understand how they should process the data right. The test task should be made up of actual data, and you may also want to include some corner cases to demonstrate potential issues early on, provided that you are aware of these potential pitfalls. If your annotators don't do well on the task, on the calibration task, you can set up another calibration or a recalibration task, and you can actually repeat this exercise until you see the desired quality. Of course, use common sense. Don't do that 100 times, or else everyone will just get sick and tired at the very beginning of your annotation. Well, okay, once you start observing the desired quality, you can launch a pilot. And the pilot annotation should embrace a larger data sample, and well, it will shed light on what goes sideways. In other words, it will point to the ambiguities and inconsistencies in the guidelines. It will highlight the drawbacks of your annotation design and many other things. So in other words, you get a lot of feedback from annotators, and your task is to incorporate this feedback and revisit the guidelines and change the annotation design if necessary. Good, large-scale annotation. If you set up the pilot annotation properly, your large-scale annotation will go like a house on fire. One thing you have to pay particular attention to is the QC process. And just a disclaimer, in the next part of the presentation, you'll learn more about QC. But now I'd just like to mention that thorough QC and proper communication with annotators will enable you to navigate the annotation in the right direction. So once the annotation is over, it might be too tempting to grab the data, call it a day, and go train the model or evaluate the model. However, it's important to remember about a retrospective session. It's essential to take a step back and reflect on what went well and what didn't, in order to optimize your future annotations, especially if the annotation that you've set up is going to be iterative. And yeah, well, in doing so, in reflecting on things, you'll be able to transform your experience into solid knowledge. Good. Yeah, so now let's talk about communication best practices that will help you establish proper process with your annotators. Well, in the IT world, it's often forgotten that annotation is a process that humans make possible, right? Therefore, it's fair to say that communication with annotators is a very important skill to master. And yeah, so let's see how you can improve your relations with annotators that will further impact your data quality. First of all, treat annotators ethically, and that's about their fair pay, right? Ensure proper onboarding. So make sure you present the task properly. Make sure you establish a communication channel if that's possible. Make sure you provide context for the task. As I said before, it's important for them to have this context because that will impact their motivation and engagement. It's important to highlight how important the annotation is for your project because that they need this sense of purpose that will impact their engagement, right, and consistency of work. Make sure you communicate with them frequently. Let's say if your annotation spans more than 2 weeks, well, on a Monday, you can reach out to them, say, happy Monday, ask them, how are you doing? And then invite their questions. You can even create a document with frequently asked questions that they will further use as a reference document. And all these things will facilitate interaction. Yeah, and of course, so be grateful. They do, annotators do a very important piece of work. So say thank you, and that will definitely help you get high quality data. Good. Let's spend another few minutes discussing a phenomenon that's associated with the human factor. To be more exact, let's talk about bias. We all have our biases, both annotators and those who manage annotation projects. It's a natural thing. However, we can talk about ways to eliminate bias. And here is how you can do that. Well, you should balance your annotators and ensure diversity. Let me give you an example. Well, suppose you're building a training set for your model and you need 10,000 paragraphs, right? And it's a training data set for GEC. You add just 2 people, 2 annotators to the project. Well, that's bad in all senses because annotators will get sick and tired of this annotation because that's a lot of data to annotate. And you end up getting a data set that's prone to subjectivity, right? Because you will train a model, so you will train your model on the data that was annotated just by 2 people. In other words, these data will represent judgments and the understanding of grammatical error correction just of these 2 people. You should also engage a large number of annotators. So the more people annotate your data, the more diversity you'll get. Number of references. Why is it important? There are some linguistic phenomena that can be highly ambiguous, right? And if you need high precision data, you can collect more than 1 reference, and in doing so, you'll be able to remedy the disagreement between annotators. Priming. What does it mean? Priming is about highlighting a certain aspect. And let me just share a story with you. So that's a real case that was described in a study called Stuffed Toys and Speech Perception. So people were asked to annotate the data and distinguish between Australian and New Zealand accents. And annotators were placed in 2 different rooms, and researchers put their two different stuffed toys. They put a stuffed toy of a kiwi bird in one room and a kangaroo in the other room. And as you might have guessed, the results were expected. Those annotators who could observe a kangaroo were leaning towards the Australian accent, and those with the kiwi bird in the room tended to label the data as a New Zealand-like accent. In other words, if, let's say, you set up a GC annotation, which encompasses many facets: punctuation, lexical suggestions, subject-verb agreement, and many other things. But if your conversations revolve around punctuation all the time, rest assured your annotators will be focused on punctuation primarily, and you might get more than necessary edits that relate to punctuation, or they may disregard anything that's not related to punctuation. Okay, and yeah, the last thing, whose ground truth? It's important to take the results of your annotation with a grain of salt. You set up an annotation, and then you measure the precision of your model, and it's very high. That might be a great signal, and that might just mean that your model is perfect, right? But at the same time, it might just mean that this particular pool of annotators thinks that this model output is very high quality. If you change the pool of annotators, things might change. So it's necessary to be aware of all these things.
All right, to wrap up our presentation, I'll talk through points to consider when assessing the quality of your data set. From how to go about defining quality in the first place to who should be assessing the quality and when. Before you collect annotations, you should try to set a quality goal for your data set. Consider what level of quality you need to meet to achieve success. You can base this goal off of a previous annotation task with a similar level of complexity. But if you don't have a previous task to base this on, you can ask experts to do your task, measure their quality, and set that result as the upper bound. You should also set the goal based off of how the data will be used. For example, gold data should be higher quality than training data. As you're setting your goal, you'll need to specify what metrics you'll use to measure quality. You can use both automatic metrics, which can be calculated automatically given a labeled data set, and manual metrics, which are calculated using human judgments on the data set. A common automatic metric to use is inter-annotator or inter-rater agreement. Agreement metrics only work when you have more than 2 references or annotations per input, and only on labeled data sets, not transformed or generated data sets. So assume you're working with a labeled data set with a redundancy greater than 1. There are a few limitations to consider when choosing which inter-annotator agreement metric to use, which are how many annotators labeled each instance, how many annotators you have, and whether every instance is labeled by every annotator. If you have only 2 annotators and both annotators labeled every input, you can use Cohen's kappa or Scott's pi. If you have more than 2 annotators and all annotators labeled every input, you can use Fleiss's kappa. If you have more than 2 annotators and not every annotator has annotated every input, you can use Krippendorff's alpha. All of these metrics work for nominal labeling tasks, and Krippendorff's alpha also works for ordinal and interval labeling tasks. Krippendorff's is also the only metrics that allows for missing annotations, meaning not every annotator needs to label every instance for you to calculate agreement. Regardless of which automatic metric you use, you shouldn't rely on just one data point to decide the quality of your data set. If you're getting high agreement before jumping to conclusions and deciding that your task is done, try to examine why you have such a high result. High inter-annotator agreement means that annotators understand the guidelines and are aligned on how to apply the guidelines to the data. It doesn't necessarily mean that your annotations themselves are of high quality. This is why it's essential to manually review your data, so you can understand if the metrics aren't catching something. So to do this, you can pull a random sample of data, or perhaps you'll evenly sample from each contributor and do a manual qualitative analysis. If you can't do this qualitative analysis yourself, make sure that whoever does this is an expert at the task. So this could be annotators who performed particularly well on the task, or annotators who are experts but did not do the annotations themselves. If you don't do this analysis yourself, you should still review the results to make sure that you agree with the experts and you can trust this data quality signal. Now that we've established that you should be doing manual quality control, you'll also have to decide when to do it. You can opt for either concurrent QC, which is done as annotation is happening or between annotation stages that Lena went over, or post-annotation QC, which is done after annotation and before model training or evaluation. Both are important, but we highly recommend doing concurrent QC. This is what you should prioritize because it allows you to address issues with the annotation as it's happening or in the next round. So based on these results, you can update your guidelines as needed, or you can clean your data as needed, or you can update your FAQ doc that you share with your annotators. But post-annotation QC is still a good idea so that you can understand what the upper bound of your model quality is, since your model will only be as good as your annotations. You can also use these QC results as a retrospective for future iterations of the task or for similar tasks in the future, just as Lena mentioned with the guidelines. Throughout this presentation, Lena and I have walked you through a typical annotation pipeline from designing your task to the annotation process to assessing the quality of your data set. So here are a few key points to remember. When you're designing your task, do your best to ensure that your data set and your task design reflect the downstream application of your data set. Be intentional about how you sample data because you can introduce bias if you don't sample data properly. The sampling strategy should mirror the context in which the model trained on your data set will be applied. Ideally, your task and interface should be as simple as possible for more efficient annotation. During annotation, you should get feedback on your guidelines before you begin your large-scale annotation and establish a line of communication with your annotators so that they can ask questions and raise concerns. Before you start your annotation, you should set a quality goal for your data set. This can be based on expert judgment or previous tasks of similar complexity. And when assessing quality, you should rely on more than one signal, not just one. And you should rely on both automatic metrics like annotation agreement and also qualitative metrics like expert judgments. Thank you very much, everyone. That's what we have for you today.
Yeah, thank you.
Excellent. Thank you so much for that presentation. I appreciate it, and I love the opportunity to hear more about the ways that you're thinking about how we get high quality data and how the rest of the field can get high quality data. There's one question that I'll start with is, what are some of the annotation platforms that you recommend to use?
Sure. So one platform is the App and Data Annotation platform. If you're interested in actually incorporating active learning into your annotation, there are a couple of platforms that offer this. One of them is Watchful, that will allow you to iteratively train a model and also write heuristics as you're annotating.
Great, thank you. And then you talked about calibration pilot tests. Do you measure annotation quality to inform guidelines revisions, or what signals influence those modifications?
Sure. Yeah. Well, I can take this question. Well, the main purpose of the calibration task is to prepare your annotators, and yes, of course, you can measure the iterated agreement just to see how well annotators understand the guidelines and understand the main idea of the annotation project. And that can be a signal, right? If the inter-annotated agreement is very low, then you might want to spend more time preparing the pool of annotators for the project.
Thank you. And in addressing the topic of noise and bias that came up, I think there was a question, what other reasons would you want to include noise, and how might you decide what the noise threshold should be?
I think you might, so you want, okay, if by noise we mean like some data artifacts, right? So we might want to include these data in our evaluation set, right? Because an evaluation set must be representative of the actual data. Yeah.
Okay, and then there's another question that came in from Obid that is, for annotation tasks where annotators see model predictions before providing their own annotation, what are some ways to make sure annotations are not negatively affected by potential bias introduced by inaccurate model predictions? And I think, Lily, you might be able to speak to that.
That's a really good point. I would make sure to allow annotators to provide their own annotations and not just validate model predictions. So you might provide these model predictions as a starting point for annotators, but you also might find that this isn't helpful if your model is not performing well, and you might want to just start from scratch and have your annotators provide their judgments instead of providing these model annotations in the first place.
Thank you. Then Mariana asks, what do you recommend doing if annotators are not performing well enough? Replacing them, for example, might cost a lot, so there might be very time consuming and costly. So what recommendations do you have?
Yeah, I would say replacement should be our last measure, right? So we should not resort to that immediately. If annotators aren't performing well, then it's a signal for you that you have to prepare them better for the task, right? And again, that can be achieved through proper communication. You may elicit problems, and so you can look at the data, right? And I try to identify some patterns, and then you can go back to annotators and discuss these instances with them.
Okay. All right. Let's see. So Yoshi says, thank you for the great talk. Do you have any tips to improve the quality of annotation tasks with a higher degree of freedom in the annotation space? So for example, writing reference summaries or text summarization. For such an annotation task, the annotator can write anything theoretically instead of choosing multiple options or labeling tasks. So I guess when it's more free form, right? So do you have any recommendations for improving the quality in that kind of context? And there's a follow-up that's, how do you evaluate the quality of collected annotations in those reference summaries?
Right. So I would definitely resort to manual qualitative analysis for such a task. But you also might implement some automatic metrics during annotation. For example, if you want to make sure that any generated reference is longer than a certain character count, you might provide that as information in the actual annotation interface so that annotators know that they're meeting this, this requirement of their data.
And another question that came in is, how do you define the optimal number of annotators? Does it depend on the size of the data set, or are there other factors?
Yeah, I would say it depends on the volume of the data that you need to get annotated. Well, ideally, like I said in the presentation, you should not will invite just 2 people just to get a 10,000 paragraph data set annotated, right? But at the same time, so you have to ensure diversity of judgments. At the same time, you have to be, one thing that you have to be aware of is if you add too many people to the project, that's your load, and that's your cognitive load. You need to make sure you have enough time to let's say, work with each annotator, right? And let's say do qualitative analysis of a sample generated by each person.
Yeah, and you were speaking to the data diversity there, and the function of, it's a function of the resources that are available, the subjectivity of the task, the budget, the diversity that you're looking for, and the size. There's a lot that goes into that.
Yes, of course.
And then there was a request, Lily, for you to either repeat or possibly type in the chat the evaluation metrics that are best to use in which cases. I think that was a really helpful piece that you added about the conditions when you would prefer Krippendorf's alpha versus Scott's pi versus Fleiss's and that kind of thing. So I don't know which would be better, if you'd like to repeat it and or type it in the chat.
I'll go ahead and type it in the chat so
Great.
that everyone can just reference that.
I'm sure that'd be helpful for a lot of people. Thank you. And then, oh, this is interesting. And Lena, you might speak to this. In the case of errors coming from learners of English as a second language, how should we treat those errors in our annotation? For example, explain me this, showed us them, etc. Should we exclude those data points at all?
Yeah, well, that's a good question, and I think that primarily depends on the purpose of your annotated data set, right? If you don't need such annotations to be presented in the data, then yeah, of course you can you should exclude them, right? And you can do that programmatically. You can identify some patterns and just clean your data.
And then another question from Maria is, how do you recommend to deal with tasks when the golden labels are subjective? For example, when you find it not very easy to assign the correct label yourself, or it's a very subjective answer in general, whether it's you or another expert that's having difficulty with that. The fuzzy labels, let's say.
How do you decide what is high quality on a subjective task?
I think that would be it. Yeah. How do you recommend dealing with those when the golden labels are subjective themselves? So how do you define what is golden if that's a subjective category?
I would say collecting more than one reference is a good way to do that. With a subjective task, there really is no right answer about how to treat a given input. So collecting multiple references and also allowing for some level of disagreement between the annotators themselves.
Yeah, I can just add that, well, disagreement isn't necessarily a bad signal. So it can just point to the fact that the task per se is very ambiguous, right, and subjective.
Yeah, I think that leads, that dovetails well into another question, which is what's the benefit of redundancy for different types of tasks or models?
Sure, well, with the labeling task, you can use redundancy to calculate agreement. And then for transformation and generation tasks, you can use redundancy to train your model. So you can show your model more than one way to treat a given input, and your model will be more diverse then, and it won't be biased just towards one annotator's annotations.
Great, thank you. And then this, Lily, I think is probably speaking to the efficiency enhancements you were talking about. Could you speak more about what human in the loop looks like in practice? In other words, the minimum architecture that we would need to benefit from that enhancement.
Right. So you can use an existing annotation platform. One of them I mentioned earlier was Watchful. This allows you to train a model as you're labeling and as you're writing heuristics. And if you want to do this yourself, you can create some kind of interface for you to label iteratively. So this could be in a Jupyter notebook, this could be in the command line, and you'll have to have a model that you are feeding this input one at a time or in small batches. And you'll also need to use your model you need to calculate the confidence on each data point and extract those data points that the model is not as confident about to use for your human annotation. So you need a model and you need an interface to provide the labels. And you also need a pool of unlabeled data that will be fed to your model.
Great. And then the topic of bias came up a couple of times. What can be done after the fact to mitigate bias effects if and when they show up? So I guess this is, you do what you can in advance to protect against this. But then after the fact, you notice that there is some imbalance in the data. Is there anything, or what do you recommend doing if you notice after the fact?
Yeah, I can take this question. What can be done? Well, again, if your budget and time permit, then you can collect just another reference, right? Generally, that can be another source of feedback for you. Well, a lot of annotations can be iterative, so you can just again have a retrospective session. We'll make sure you don't just make these mistakes when you launch an annotation next time. And again, you can, well, if you identify certain pattern in the data, you can extract this data and you can have it re-annotated, again, if your time permits and budget permits.
All right, thank you. There are no other questions in the queue right now, and we are almost at time for an hour. Another question did come in, so I'll throw it in since we have a minute. Actually, if you're able to join us for networking, I would love to see you in there, and we can ask this question in there. But as a precursor or just a teaser, how do you find the ideal balance between focusing on improving annotation quality versus collecting more annotated data? Maybe that should be an enticement to get people to come join us in the networking session. So the official part is now over. Thank you for joining us, and we'll send the slides and link to the video of the recording for this event after. I do invite you to come join our online networking. The link's in the Zoom chat, and it's also in the registration confirmation. This call will be on for another couple of minutes, so you have access to the links that are in the chat. And otherwise, thanks everyone, and we'll see you at our upcoming events.
Thank you.
Thank you.
Bye everyone.